that we're programmed. We're programmed to die. This is the core of the radical idea that you'll be hearing a lot more about. Because we're programmed to die, and because evolution is deliberately programmed to die, putting us into a more natural environment or giving us more natural foods does nothing else but to aid that program to go on and do what it wants to do anyway. So natural foods may be good for our health when we're young, but they're not going to forestall aging. We imagine that if we just give our bodies the perfect environment, every nutrient we need, freedom from injury and insult, then our bodies will last a lot longer. And this represents a fundamental misunderstanding of what aging is and where it comes from. Aging is a genetic program implanted in us by evolution with the express purpose of killing us. And we may be optimized for strength and fitness and speed when we're young. But aging is not the accumulated effect of things that are beyond our control that somehow degrade the body despite the body fighting its hardest to ward it off. Aging is something that the body does to itself because it's programmed to do that. So I'm going to spend the next hour laying out the evidence for this perspective and say a few words about how to reconcile it with evolutionary theory, which is, after all, that's my job. That's what I've taken on as my career. And then I'll move on to the implications of this perspective for anti-aging medicine. And the good news is that this makes the researcher's job, the medical researcher's job, a lot easier, and it makes for a lot more promise in anti-aging research. After all, if you think that aging consists of a whole bunch of things wearing out at once, a whole bunch of things going wrong with the body, then the right approach is to engineer a solution to each one of those things. And any one of them could kill us. So we really have to answer hundreds of different problems about the body, if that's what you think aging is. But if you think that aging is the body destroying itself because it's programmed to destroy itself, you can look for biochemical switches. You can look for upstream regulators that will actually affect the process of aging from the top down and may affect a whole host of different aging traits in one fell swoop. And of course, we're all here because we have a sense that caloric restriction does that. So next I want to talk about where does aging come from an evolutionary perspective. And I'll start with what aging is not. And spend a good deal of time on that because there are popular misconceptions and there are also scientific misconceptions that I really need to address thoroughly. I mean, if I'm bringing a radical thesis to you, it's my job to do that thoroughly. I've done that in a couple of scientific papers that came out in the last 2 years, and for people who are inclined in that direction, I want to share that with you, but I won't talk at a technical level for this audience for now.
Sexual reproduction in a linear chromosome makes it possible to match up different genes more readily. I can maybe refer you to that, but the evidence on your population explosions and the modulation sounds like the periodicity in the population, but in fact the empirical data show that the species extinctions in the evolutionary record are basically power law distributed. They're episodic, punctuated kinds of extinctions. So maybe you need to take the exponential growth out of it, but I do think you actually have a theory that makes a lot of sense to me. There are certain aspects of it that I find very appealing.
Well, thanks. I do want to give you a copy of the paper that I just published this month. Yeah. It's not about cycles so much as about chaos in the population dynamics. It's an intriguing thing that
there is chaos.
The chaos theory comes in here, and that there's a chaos threshold. That if you're reproducing at the same rate that your environment, your prey species is reproducing, you're optimum. And if you reproduce twice that fast, you're in trouble because you start cycling and
crisis.
your average level is down. But if you reproduce 3 times that fast, it's not like you're in worse trouble. It's like your population goes into chaos and you're dead. And that's an interesting mathematical fact which was central to the paper that I just wrote. And I think it ties into what you're saying.
Great extinction